So here we're going to find a one mean t confidence interval. That is a t confidence interval for one particular mean or average. And we're going to be focused on mercury level in dolphins. So please just make a note that we're breaking the steps down into two different parts here. So it's different than what we did with the one proportion, but we are getting to the same information, and hopefully we understand the process as we break it down too, and then we can apply it to other contexts and understand what we're doing. So suppose you are testing average level of mercury in dolphins, and we have a sample. We got a sample of dolphins. We go into the wild, to the sea. Somehow we find 19 dolphins. We measure their mercury levels, and whatever measure there it is, parts per million, eh, cubic, parts per million, certain cubic meters or whatever the measurement unit is, we got an average of 4.4 level of mercury. And also we got a standard deviation of 2.3. And then the minimum value was 1.7 level of mercury. And then the maximum was 9.2 level of mercury. Now, if you don't really know anything about measuring levels of mercury, it's hard to know what's going on, and what these numbers mean. But let's just kind of forget about that a little bit and just assume that lower levels of mercury bad, higher levels of mercury, I'm sorry, lower levels of mercury good, higher levels of mercury bad, and so on. And here we have a mean which seems kind of in the middle a little bit, right? So this difference between the minimum value and the mean, and the difference between the maximum value and the mean, are not that different. It's not like 1.7 to 4.4 to 300. So that would be an extreme outlier. So we don't really see outliers here. And so that's, or very large outliers, extreme outliers at least. So that's a good thing. This is the standard deviation. So first question is, are normality independence expectations met in the data? So for you to do any of the stuff we're doing here, we got to ask that first. And the textbook tells us, well, this was a simple random sample. We did sample, on the whole big area of the ocean. So the sample is independent. So, okay, check. Let's check that off. What about normality? Well, we could create a histogram here and see how bad it really is, or how skewed or not. And remember, it doesn't have to be perfect, but as long as it looks normal, it's a good thing. But we can see here that there's, as I was saying, this is not that different. The difference between the maximum to the mean and minimum to the mean. So we don't really see huge extreme values. So the normality kind of seems to be okay as well. So what is the next? Well, next we need to compute a standard error for the test statistic, which is um, the kind of standard. We're assuming the standard deviation here for the population. The standard deviation, though, divided by divided by the square root of the sample size. And once again, what are we trying to do? Well, we're trying to get this confidence interval. So we already have the average level of mercury in the dolphins, but we're not done yet. We need to address that question. What is the range of values that we could expect, given this information that we have from this sample, given the values that we have from this sample? So we know that the average is 4.4, but what is the confidence interval? Like, should we expect to be between 3.5 and 5.5 and so on? So that's what we're doing here. Second step, compute standard error. It's pretty straightforward. We use the standard deviation, and we divide by the square root of the sample. Okay, and we're kind of estimating that we can use that as our sample data as a reference to the our population data. Then we need to identify your confidence level. It's usually 95%. 95% of the studies use 95%. I don't know if it's 95%, but we do usually use 95%. You could use 99%, but let's just stick to 95%. So you want to be 95% confidence of whatever confidence interval you get. So let's use that information. Now you need to because we're going to work with the t distribution, so we need to identify this t cutoff, and it's like the z asterisk measure for the proportion, which is the measure of standard deviations from the mean. So because we want to put it in terms of the t distribution. Okay, so we got to put it into terms of the numbers of standard deviations from the mean, and we're going to use this qt function of r to find the t cutoff when we want 95% confidence interval. And let's remember, 95% usually means in the center. It could be in the center if we want a two-sided test, or it could be all the way to the left or all the way to the right. But it's still, we need this t cutoff point because, once again, the t distribution changes based on degrees of freedom. So we have 18 degrees of freedom, and then so we plug in, why do we plug in this number here? 0.025. Well, 0.025 is 2.5%, which is 2.5% on this side and 2.5% on this side. Often we want to do a two-tailed test, so usually kind of just approach it that way. So the cutoff point we got input here is 2.5 or 0.025 for one side. That gives you the negative number. And you could have just assumed that the other number was 2.1 because the distribution is symmetrical. But if you did put it into the function, the other side of it, which is 97.5, you would get 2.1. But you could have just assumed that since you got negative 2.1 from the function applied to 0.025, then you would have gotten 2.1 if you put 975, because it counts sort of in this direction, 2.5. The area, the total area here is 2.5, and the total area here is 2.5, but when they count in these kinds of functions, here we are at 97.5, which makes sense. So at this point here, we're at 97.5. So this area here should be 2.5, and we have 100%. So that's the step that we find a cutoff point to its negative 2.1 and 2.1. And then we use the t cutoff, which is the standardized t standard deviation, into the similar equation that we used before here with our mean and our standard error. So all we do is we have our mean here. The mean is 4.4, which we already got here, just simple calculation from the data. And then plus or minus 2.10, which is the number we just got, the t cutoff point, and then times our standard error we calculated before. That was this calculation here that we didn't give the result, 0.528. It was from here on this 0.528. And here we could have calculated it's 2.3. 2.3 divided by the square root of 4.4, and it gets 0.528. So our confidence interval with 95% confidence is going to be 4.4 plus or minus 2.1 times 0.528, which gives us these numbers here. So we can be 95% sure, 95% confident that the mean level of mercury in dolphins is between 3.29 and 5.51. So that's what we just did here. And this is the kind of information we just got. And we'll continue on with other aspects of the mean test. This is one part of the mean test. And then we'll do another one to find the probability values.